In this lesson, we're going to learn about writing inequalities from a graph. So in order to write an inequality from a graph, we need to think about it as if we're going to work backwards to write our equation in slope-intercept form. We need to be able to identify what the slope is of the equation and where it's crossing our y-axis, and that's what we'll put in for b. Once we have our general equation set up, then we need to identify what type of inequality we're going to use based on the shading, the position of the shading, and if it's a solid line or a dashed line. So right away from this graph, I know I can set it up as a less than inequality symbol. And the reason why is because first it's a dashed line. So I know that any number on this line is not a solution. So then I know my inequality can't have the equal sign with it. And the shading is below. Shading is less than wherever this line is. It's all numbers smaller than that line. So my inequality that I'm going to use for this one is less than. Y is less than. Now the other piece we need to identify is the slope. So we could use this coordinate and this coordinate. There are others, but these are the two that right away we can see. So calculating the slope is the rise over the run. So from here up 1, 2, so we have a rise of 2. And to the right 1, 2, we have a run of 2. So if our slope is 2 over 2, that simplifies to 1. So we could write it as y equals 1 x. And then our y-intercept, this boundary line is crossing our y-axis at a -2. So we'd write it as -2. Now typically with equations, you won't have that number 1 there. So really you could write this as y is less than x minus 2. Let's look at another example. And then again, just the main differences with graphing inequalities versus equations is the boundary lines and the shading. The boundary lines, if there's no equal sign, you're going to use a dashed line. If there is an equal sign included, you're going to use a solid line. And then the shading, if it is using the less than or equal to symbols, then you're shading below the line. So since in this lesson we're working from the graph to write the inequality, then we need to look to see what part is shaded. So if it's shaded below the line, then you're going to use less than or equal to. If it's shaded above that line, then you're going to use greater than or equal to. So using another example, this is the same inequality that we had before, just the shading is a little bit different. So we need to set it up into slope-intercept form. And we need to identify the shading, the type of inequality, and the slope and y-intercept. So this, it's shaded above, so I know it's going to be greater than, y is greater than, and it has a solid line. So since it's a solid line, I know it's also going to include, so greater than or equal to, anything on this line. My y-intercept is here at -2. So I know my equation will end as a -2. Now I just need to calculate the slope. Up 1 to the right 1 has a rise of 1 and a run of 1, making our slope 1. So in place of m, you could put 1, but again, just like the other equation, if there's a 1 in front of the variable, you don't have to write it. So y is greater than or equal to x minus 2. Another example, so looking at this one, again, we need to identify our equation in slope-intercept form. Okay, so if we start with our shading it's a little bit harder to see because it's not as clear what's below the line. But if you think of this as being a really, really steep teeter-totter, somebody would be sitting here and somebody would be sitting here. So everything below that is below the line. It's below that teeter-totter. So in this case, it's shaded below the line. So it's going to be the less than symbol. And it is a dashed line, a dashed boundary line. So we just want the less than. We don't want less than or equal to. Our y-intercept here, it's a little bit trickier to see just because of this type of dash line we have, but here is our y-intercept. So it's crossing at a positive 1. And our slope, if we count from this point to, let's see, this point for sure, because it's crossing at an intersecting line, we'd go left 1, so that's a negative 1, and then down 1, 2, 3, 4, 5, 6. So since we counted down, that's a negative 6, giving us a slope, so rise over the run of a negative 1 over a negative 6. Two negatives make it a positive, so a positive 1/6. So our slope is 1/6 times x for our inequality. So y is less than 1/6 x plus 1. One final inequality. So notice this one. This is a horizontal line. It is going through our y-axis. So since it's going through our y-axis, I know it's going to look like an equation y equals something. And all horizontal lines have a slope of 0, so I won't have anything times x, because if it's mx plus b and my slope is 0, 0 times any number is going to make this entire thing equal 0. Okay, so we have to figure out where it's crossing our y-axis. It's at 5. So y, and it's shaded above this line, so all numbers greater than 5, y is greater than, and it's a solid line, so I want to have y is greater than or equal to 5. This is showing me that any y coordinate of 5 is a solution, and anything above a y coordinate of 5 is a solution to this inequality.